What we've been looking at in the past couple of vodcasts is this idea behind stoichiometry. So just as a quick review, stoichiometry is basically applying mathematics to balanced chemical reactions. It gives you the ability to calculate certain values, given certain values, in a balanced chemical reaction. Well, what we want to look at in this vodcast is what we refer to as limiting reagents. The idea is when you react two things together in a chemical reaction, one of those things is going to run out before the other thing. And there's a classic example of the ham and cheese example. So for example, let's say you are making ham and cheese sandwiches and it specifically takes one slice of ham, one slice of cheese, and two slices of bread to make a sandwich. The idea here is that it's supposed to represent a chemical reaction. In other words, you've got the ham, one slice, you've got the cheese, one slice, and you've got two slices of bread to react to give you one sandwich. So the idea here is if you have 100 slices of bread, so we'll put our 100 here. If you've got 125 slices of cheese, so right away you start thinking, okay, well, how many sandwiches will this make? And you've got two slices of ham, how many sandwiches can you make? Well, clearly, if you've only got two slices of ham, after you use those two slices, you're only going to be able to make two sandwiches. Again, the idea being the ham is going to limit how much of the product or the sandwiches you can make. So regardless of how much bread we have or how much ham we have, or I'm sorry, how much cheese we have, the ham is going to limit our product. Well, the same thing happens with chemical equations. So when you have two things react together, you want to remember that they're going to react in the ratio 2 moles of copper for every mole of sulfur. So if you have 1,000 moles of sulfur and 1 mole of copper, clearly you're going to run out of the copper first. The reaction is going to stop and you're going to have an excess of sulfur left behind. So what we want to do is calculate which one of these will run out first. We'll refer to that as the limiting reagent, or we call it the limiting reactant. Both things mean the same thing. They're synonyms for one another. So anyway, there's a number of ways to do this, and I am going to show you one way. There are multiple ways, and maybe in another vodcast or so, we'll go over some other methods for doing this. Anyway, let's start with our 80 grams of copper and our 25 grams of sulfur. So what we want to do is take one of them, and I always tend to take the one on the left. So I'm going to take my 80 grams of copper, and now what I want to do is calculate, if I've got 80 grams of copper, how many grams of sulfur would react with that? And then I'm going to compare it to the 25 grams that I have. So let's do what we did in the last vodcast. We want to calculate the number of grams of sulfur that 80 grams of copper will produce. So we'll do our dimensional analysis. Grams of copper is going to go in the denominator, so they cancel, to moles of copper. And remember, we want the molar mass from the periodic table. 1 mole, 63, let me rewrite that, 63.5 grams. So that means our grams cancel. We have moles of copper. The mole ratio is 2 to 1. So we'll put 2 moles copper in the denominator, 1 mole sulfur in the numerator. Moles of copper cancel. Now we have moles of sulfur, and we want to convert that to grams. So 1 mole of sulfur. Sulfur has a molar mass of 32 grams. So our moles cancel. Let's do the math. 80 divided by 63.5 divided by 2 times 32, and we get let's put 20.2. So we're going to put 20.2 grams of sulfur. That's the value that I would need to react with 80 grams of copper. So I need 20 grams of sulfur. Well, I have 25 grams of sulfur, so I have more than enough sulfur. So what that means is the other one is going to run out first. Let's just do that again. I need 20 grams of sulfur to react with 80 grams of copper. So I've got more than enough of the sulfur, so we're going to call that one the excess reagent, which means the other one has to be the limiting reagent. So if I were to do this the opposite, in other words, let's say I started with my 25 grams of sulfur instead, and I did 32 grams of sulfur per mole, and then we did the mole ratio, 1 mole of sulfur for every 2 moles of copper, and then 1 mole of copper is 63.5 grams of copper. Let's do the math there. 25 divided by 32 times 2 times 63.5, we get 99.2 grams of copper. So that means I would need 99.2 grams of copper. Well, I've only got 80 grams of copper, so I don't have enough copper, so that verifies that that's the limiting reagent, and the other one is the excess reagent. So then what you do once you have the limiting reagent is you use it to calculate how much of the product you would want. So we would take our 80 grams of copper and do the math to calculate copper sulfide. And let me see, can I make some space here? Nope, I don't want to delete that whole thing. So I'm going to try to squeeze it in here on the bottom. And I'm just going to do this quickly. So let's start with the limiting reagent, 80 grams of copper. And now we want to calculate how much copper sulfide there is. So do what we do. 63.5 grams of copper per mole of copper. Mole ratio is 2 to 1, so we would say 2 moles of copper to 1 mole copper 1 sulfide, and then we would say 1 mole copper 1 sulfide. Let's add up its molar mass, 63.54 times 2 plus 32, 159 grams of copper 1 sulfide. Do the math, 80 divided by 63.5 divided by 2 times 159. So we would have 100 grams of our product. Now we kind of squeezed that in a little bit there, so we're going to do another problem and go through this one more time. Okay, so now this time we're starting with moles. And you want to pay attention to that because sometimes the problem will say start with grams, sometimes moles. So you've got to look and pay attention to what you're starting with. So we have 2.7 moles of the C2H4 and 6.3 moles of the oxygen. So we're going to calculate which one would be the limiting reagent. And then we're going to find how many moles of water. So that's what we're looking for in the end. So let's start with one of them. And again, I'm going to pick the one on the left. So I'm going to start with 2.7 moles of C2H4. Now what I want to do is, that's supposed to be a 4 there. Let me see if I can get rid of that. Here, let me just rewrite the whole thing. So I am going to start with 2.7 moles of C2H4. And now what I'm going to do is calculate how many moles of O2 I would need. So let's do the dimensional analysis. We want moles of C2H4 in the denominator. And now we can go right to moles of O2. Notice I don't have to convert to grams because to go from one thing in the equation to the other, we do that with moles. So the numbers in the conversion are 1 and 2 from the coefficients in the reaction. So if I do that math, I get 5.4 moles of O2, and that's how much I need. Well, that's how much I have. So again, I've got more than enough of the oxygen, so the other one, the C2H4, has to be the limiting reagent. So I'm going to take its value, 2.7 moles, C2H4, and now I'm going to calculate how many moles of water I would get with that. So let's do the mole ratio. 1 mole C2H4, 2 moles H2O, and again, that's from the numbers in the equation. 2.7 times 2 is 5.4 moles of H2O, and that would answer the question. Let's take a look at one last problem. Okay, so now we're looking for grams of water. We have 2.4 moles of the C2H2 and 7.4 moles of the O2. So again, now we're starting with moles, but we're going to change it to, or we're going to try to calculate, we're going to calculate grams. Again, let's find the limiting reagent. 2.4 moles C2H4, and I'm going to calculate how many moles of the O2 I need. So mole ratio is 2 to 5. So 2 moles C2H4, 5 moles of O2. Let's do the math there. 2.4 times 5 divided by 2 is 6 moles of oxygen. Now remember, that's 6 moles that I need. Or I should say I need 6 moles to react with my 2.4 moles. Well, I've got 7.4 moles. Again, I've got more than enough oxygen, so that makes that the limiting reagent. So now I'm going to take my limiting reagent, the 2.4 moles of C2H4, and I'm going to calculate grams of H2O. So doing the dimensional analysis, we're going to go from here to here. We use the mole ratio, so moles C2H4 to moles of water, 2 and 2, again, from the balanced chemical equation. That means my moles cancel. Now I have moles of water, and I want to convert that to grams. So remember, when you convert from moles to grams, we use the molar mass. So we'll put moles in the denominator, grams in the numerator. 1 mole, molar mass, 2 times 1 plus 16 is 18. Our moles of water cancel. We do the math. 2.4 times 2 divided by 2 times 18, and we get 43.2 grams of H2O.